Hey everyone, the next problem we're going to work is problem 2.46B and C, and this comes also from chapter 2.7, changes of state. Okay, we've looked at, if you've watched the previous video, you've looked at the heat of fusion, and these problems go along with the heat of vaporization or the heat of condensation or the heat to condense. And so if you see the terms condense or vaporize, you want to think of the heat of vaporization. Okay, so I'm going to write this out for you here. Okay, so one second. All right. So the heat of vaporization of water is equal to 540 calories per 1 gram of H2O, which is water, or 1,260 joules per 1 gram of water. Okay, so the heat of vaporization is just basically the energy needed to convert 1 gram of a liquid to a gas at its boiling point. It's called the heat of vaporization, but you can also look at this as condensation. Okay, and so vaporization is going from a liquid to a gas. Okay, so vaporization, we would think of this if you're boiling water and it produces the vapor. So as you're boiling it and it gets to its boiling point, you start seeing the steam, and that is going to be the, sorry guys, I'm having a problem with my pen here. Okay, so heat of vaporization is going from a liquid to a gas, but we can also use the same formula for the heat to condense, which condensing is going from a gas to a liquid. Okay, so to go from a liquid to a gas, you have to heat the liquid, just like you think about this with boiling water, heat it to produce the steam. But condensing, you actually want to cool a gas to a liquid. We'll talk more about this when we get to the gases chapter in your book. Okay, but we can use this formula here, so we can use the heat of vaporization of water for either problem. So if we're asked for, if you hear the word condense or vaporize, you want to immediately think of these values that are given to you here. Okay, and these will be given, like I said, so you don't have to memorize these. Okay, so we want to calculate the heat change and indicate whether heat was absorbed or released. So we'll talk about that in the end. But for joules, heat in joules to condense 7.60 grams of steam. Okay, so we're going to condense. We want to automatically, we think of the heat of vaporization. Okay, so condensing, we're going from a gas to a liquid. Okay, so steam is our gas. And then we're going to use we're wanting to go to joules, so we're going to use our heat of vaporization. And that leaves us with a large number here, 1.72 times 10 to the 4th joules. So this is the heat change that is required for 7.60 grams of steam to be condensed. Okay, and in this situation, we're condensing, so we're going from a gas to a liquid, and this requires cooling. Okay, and so when you have to cool something, just like we did when we froze something, we're going to be releasing heat. (2.46C) says that we want to find kilocalories. So we want to calculate the heat change in kilocalories to vaporize 44 grams of water. So the first thing we want to think about is that vaporizing, we want to use the heat of vaporization. So once again, these will be given to you. And it's asking us for kilocalories. Well, we know that, on the previous slide I showed this, that the heat of vaporization for 1 gram of water is 540. So we can just plug this into here. So 1 gram. And we would be left with calories. But we want to know kilocalories, so kcals, and we know that we have 1,000 calories in 1 kcal. So it's just converting. You can do it in separate steps if you'd like, or do it all together like I've done here. Okay, and if we do the math, and we're supposed to end up with 2 significant figures, we end up with 24 kcals. So this would be, we need 24 kcals of heat in order to vaporize 44 grams of water. So basically all you're doing is you're taking these, previously we looked at heat of fusion, here's heat of vaporization, and this is based on 1 gram of water. Well, in these scenarios, you have more than 1 gram, so or you have less, or you don't have exactly 1 gram. So you have 44 grams, so we need to convert and use our heat of vaporization to take into account for 1 gram, but now we're looking at 44 grams. We're looking at more. Okay, and if we're going to vaporize, so we're going to be heating something, like we're turning a liquid to a gas, and so it's going to have to absorb heat from the surroundings.